Okay, so just check. I think it is visible. So it is saying that draw the pole zero plot of the transfer function which is given. So I'll make the numerical little big, and I think it is now easily visible. So draw the pole zero plot. So you can take the screenshot of this. It is saying that if a closed loop transfer function is given. So previous numerical we learned how to find the pole zero plot. Sorry, how to find the transfer function. So transfer function we found by CS by RS. So this is the next numerical where I have given you CS by RS, or I have given you a transfer function which is having two poles. So poles are that which are having two poles and two zeros. So numerator is given by s into s plus 3 and denominator is given by s plus 4 into s square plus 2s plus 10. Now this is a case scenario. Four things are asked. So first thing asked is find pole zero plot. Okay, so from CS by RS we find there are two poles, there are two zeros. We should know how to find poles, and we should know how to find zeros. Then you have to check whether the poles and zeros are complex poles and zeros or real poles and zeros, and whether the poles and zeros are in the left hand side or right hand side. If all the poles are there in the left hand side of the S-plane, then the system will be a stable system. So first question is draw the pole zero plot. Second question is find the characteristic equation. So what is meant by characteristic equation? Characteristic equation is nothing but the denominator equation of the transfer function. So transfer function is given by CS by RS. Whatever is the denominator equation, if you equate to 0, then we find the characteristic equation. And what is the necessity of finding characteristic equation? Because characteristic equation, if you are finding from the characteristic equation, we can find out what are the poles of the system. So roots of the characteristic equation, that gives us the poles of the system. And then we check the position of the poles, whether they are in the left hand side of S-plane or right hand side of the S-plane. If poles are there in the left hand side of the S-plane, then we say that the system is perfectly stable, like this. Okay, so let us go forward. What is there? You can see the solution given below. At least the question you can say, or at least the CS by RS transfer function you can take. First step, you can see that the numerator is having s into s plus 3. So the poles are there. So s into s plus 3 is equal to 0. From there you can find either s is equal to 0 or s plus 3 is equal to 0. So if s plus 3 is equal to 0, that means s is equal to minus 3. So finding the roots of the numerator polynomial, that gives us the zeros. So zeros are at s is equal to 0 and s is equal to minus 3. That is the first thing. What are the poles? So you are finding that there are two terms in the denominator, denominator of CS by RS. So s plus 4 into s square plus 2s plus 10 is equal to 0. So the whole denominator is equal to 0. That is the characteristic equation. So from there a into b is equal to 0 means a is equal to 0 and b is equal to 0. So s plus 4 is equal to 0. From there you find s is equal to minus 4. And next equation is s square plus 2s plus 10 is equal to 0. So s square plus 2s plus 10 is equal to, so this you have to factorize with complex in the complex domain. So s square plus 2s plus 10, this can be written as s square plus 2s plus 1 plus 9. So s square plus 2s plus 1 is nothing but s plus 1 whole square. Okay, so if you are doing this thing, if you are separating this thing clearly, so this becomes s square plus 2s plus 1 plus 9. So 1 plus 9 becomes 10. So s square plus 2s plus 1 becomes s plus 1 whole square, and 9 becomes 3 whole square. Okay, and 3 you can write as minus 3j whole square. So that is the next line, s plus 1 whole square plus 3 square, because you have to write in form of s square minus b square. So s plus 1 whole square plus 3 square is in the form of s square plus b square. We don't get any factorized form from s square plus b square. That's why you have to write this thing in s square minus b square form. So this is s plus 1 whole square minus of 3j square. So what is j square? J square is nothing but minus 1. So this is the way you are supposed to do it. Now s square plus 2s plus 10 becomes, so now this is s square minus b square. So this is a plus b and a minus b. So this is s plus 1 plus 3j and s plus 1 minus 3j. So this is one very important way of finding the roots in the complex domain. So here you can find s is equal to 0. This is a real 0. This is s is equal to minus 3. This is a real 0. What is meant by real? It's only number. Okay, there is no imaginary part. There is no j part here. That's why this is called real 0. So both these zeros are real 0. Then from s plus 4 is equal to 0, we are finding s is equal to minus 4. This is a real pole because this s plus 4 is there at the denominator. Okay, so s is equal to minus 4 is a real pole. But a square plus 2s plus 10, if you are doing factorization, what you find is s plus 1 plus 3j and s plus 1 minus 3j. Now s square plus 2s plus 10 is equal to 0 means s plus 1 plus 3j multiplied by s plus 1 minus 3j is equal to 0. So from there you find two factors. One is s1 is, so from here s1 is equal to minus 1 plus 3j from this one, and from here you find s1 is s2 is equal to minus 1 minus 3j. So these are two complex poles. So from the denominator we find there are three roots. One is s is equal to minus 4, this is shown here, and that is from here you're finding s1 is equal to minus 1 plus 3j, and from here you are finding s2 is equal to minus 1 minus 3j. Now the question is draw the pole 0 plot. So pole 0 plot generally we show in terms of S-plane. So this is the first thing you are supposed to do. First you have to draw the real axis. Real axis is given by sigma axis. Then you have to draw the imaginary axis. Imaginary axis is j omega axis. So first is sigma axis, then there is j omega axis, and after drawing the sigma and j omega, then you are supposed to plot all the poles and zeros. So zeros are generally given by round shape. So this is called 0. So 1 0 is there at 0. 0 means at origin. So this is where am I showing first 0. Second 0 is given at minus 3. So this is another 0 I am showing at minus 3. So this is 1 0. This is another 0. Next is show the poles. So where are the poles? The first real pole is at minus 4. So this is on real axis, sigma axis. So this is the first real pole which is given at minus 4. Then the other two poles are at minus 1 plus j3 and minus 1 minus j3. So from here to here, this is minus 1. If you can draw it to the scale, it's good. Otherwise, roughly also if you draw like this is not wrong. But only every point you have to write or label what is the distance. So that there will be a very good instruction or important instruction in the exam that always draw the diagrams and label it. So you draw the diagram but you forget to label it. What is meant by label? This is sigma axis, this is minus sigma, this is j omega, this is minus j omega. So whenever you are drawing a graph, let it be root locus, let it be Bode plot, let it be any diagram, any exam, any paper, first you are supposed to label the diagrams. Without labeling, diagram is having no meaning. Okay. So this is the first part. First mark the axis sigma and j omega. Then there is S-plane. So this is the S-plane. You are supposed to show the pole 0 plot in S-plane domain. Okay. Then you are supposed to write what are the zeros. So zeros are at 1 0 at 0, another 0 at minus 3. Then where are the poles? So first real pole is there at minus 4. Then where are the other complex poles? So real poles are on sigma axis and complex poles are on j omega axis. So first pole is at minus 1 plus j3. So this is minus 1. Nothing you are supposed to mark here, just mark minus 1. But pole is there at minus 1 plus j3. So it is in the, it's a complex pole. So it will go in the y direction. So this is minus 1 plus j3. So here I have written j3, 3j. Okay, and another pole, because complex pole always happens in conjugate form. So if there is a pole at minus 1 plus j3, automatically there will be another pole at minus 1 minus j3. So this is minus 1 minus j3. So for this numerical, whatever CS by RS is given, from here you can find there are two real zeros. One is at 0, one is at minus 3, and there are three poles. One is at minus 4, another is at minus 1 plus j3 and minus 1 minus j3. So it's a 2 0 3 pole system. Okay, it's a proper transfer function. What is proper transfer function? Where the numerator polynomial is having lesser order than the denominator polynomial. So your numerator polynomial is having order 2 because s into s plus 3. If you multiply, it will become s square plus 3s. So it's having order 2 numerator polynomial. And denominator polynomial, there are 3s, so it will be s cube. So it is having order 3. So as there are 3 order system, so there will be 3 poles. One is real pole, 2 are complex poles, and there are 2 zeros. One is minus 3, another is at 0. So this is what is called as the pole 0 diagram, and here the gist is given. Gist means together you are showing the whole thing in a very small manner. So 2 real zeros, one is at 0, another is at minus 3. One real pole which is at minus 4, and one pair of complex poles. One pair of complex poles means minus 1 plus 3j and minus 1 minus 3j. Now there are different other questions. What are the other questions? Other questions are find in the same numerical. The other questions are find the system characteristic equation. So I have gone to a new page. I have gone to a new diagram. So just see what is meant by system characteristic equation. So characteristic equation is nothing but the denominator equation of the system. Now denominator equation is given Cs by Rs, numerator was S into S plus 3, denominator was S plus 4 into S square plus 2S plus 10. So very easy thing, there is nothing difficult. So what you have to do is denominator equation S plus 4 into S square plus 2S plus 10 is equal to 0. So if you are writing all of this and just you can give a name as PS, PS nothing but the characteristic equation. So P stands for polynomial S. So the characteristic equation is in the form of S. So PS is equal to S plus 4, S square plus 2S plus 10 is equal to 0. If you leave here like this, then also will be getting full marks. Or if you just multiply it and if you just show it in terms of a polynomial, that also will do. So if you are multiplying it, so multiply this thing with the first term. So you are getting S cube plus, okay, so this is S cube plus 2S square. And this is 4S square plus 8S, and then this is 10S plus 40. So I think if you are just rearranging it, what you find is S cube plus 6S square plus 18S plus 40. Okay, so this is the polynomial and that is equal to 0. So if you are trying to find out the roots of this thing by using MATLAB, you can find the roots of this thing. You will be finding there are three roots. One is S is equal to minus 4, and S is equal to minus 1 plus 3j, and there is S is equal to minus 1 minus 3j. So that way also you can find the polynomial roots if you are doing by MATLAB. That is also right. Okay, so already we have found what are the roots of characteristic equation. That is nothing but poles, and this is actually the characteristic equation. If there is any doubt, you can ask me. So Cs by Rs is given, transfer function is given. Whatever you are getting at the denominator, this if you are equating it to 0, that becomes the characteristic equation. There is another question asked whether the system is stable or unstable. Okay, so the system is stable, so here the answer is given as all the poles are toward left hand side of S plane or to the left hand side of j omega axis. So with respect to j omega axis, we divide the overall domain of S plane. So one is there in the left hand side of the S plane, another is there in the right hand side of the S plane. So if the poles are there in the left hand side of the S plane, all the poles, so it can be real pole, it can be imaginary pole, that does not matter. Generally you are having a wrong notion that yes, poles are there in the imaginary direction, then it seems that poles are unstable. It is not like that. Okay, so just see the pole zero diagram of the previous page like this. Okay, so with respect to j omega axis, you have to check whether the poles are there in the left hand side. So this left side is the left hand side, or whether the poles are there in the right hand side. It doesn't matter whether poles are real axis or imaginary axis. So imaginary axis poles are unstable. That is a wrong notion you are having. It has nothing to do with imaginary or real. It is to do with position of the pole with respect to j omega axis. If all the poles are there in the left hand side of the j omega axis, that means system is stable. And if any one pole, so if there are 10 poles of a system, 9 poles are there in the left hand side, but one pole is there in the right hand side, then also the system will become unstable. But in this case, you are finding all 3 poles are lying in the left hand side of the S plane. Hence, the system is a stable system. So that is what I have mentioned here in the next page. So it is said that all the poles are towards the left hand side of S plane or to the left hand side of j omega axis. Hence, the overall system is a absolutely stable system. So in the 4th chapter, we will find what is meant by absolute stability, what is meant by relative stability, what is meant by asymptotically stability, all those things. So what is meant by absolute stable? Absolute stable means you can increase the gain of the system to any degree, but then also the system will be stable. So it doesn't matter what is going to be the value of K or DC gain of the system. Any gain you can keep, the system will be stable. Order of the system is equal to 3. How do you find the order of the system? The order of the system is found from the characteristic equation polynomial, and whatever is the highest order of S in that polynomial of characteristic equation, that is actually the order of the system. So order of the system is actually giving you the number of energy storing element in the system. So what kind of system is this? We don't know. But whatever system is, there are 3 energy storing element in the system. So that is the significance of system order. Okay, so already we have found the characteristic equation s cube plus 6s square plus 18s plus 40 is equal to 0, and from here, as this is s cube, we are finding the order of the system is equal to 3. Okay, it is like that, and we were having something called as type and order of the system, so that the document I have shared with you, but some discussion is required regarding that. We will do it. So this was the second numerical. I'm giving you just 1 minute's time. You just copy the statement of this, or you can take the screenshot. So this is the question, that is, I'm giving you a CS by RS, and from that given CS by RS you are supposed to find whether the system is stable or not, what is the characteristic equation, you have to draw the pole zero plot, and you have to tell me what is the order of the system. So I'm giving you a minute's time. Very fast you can write down or take the screenshot of this thing. Okay, so just write down CS by RS as S into S plus 3 by S plus 4, S square plus 2, S plus 10. From there, 4 questions, draw pole 0, find characteristic equation, comment on system stability, and what is the order of the system. So if you want to take the previous numerical, here also the previous numerical, you can take a screenshot of this. Find transfer function by block reduction technique. So just take the screenshot and let me know. And the first step of solution is also there. Just one sec. So you can take the screenshot. You can take the screenshot. I think this is better. Okay, so I think these are the two numericals which are very important, because one step in the first numerical we are finding out how to find the transfer function from the block diagram. So it can be block reduction technique, it can be signal flow graph. So one numerical on signal flow graph we will do now. So by any of these two methods you can find out exactly what is or how to find the transfer function of a system. Now after finding the transfer function of the system, what to do with that? So after we are finding the transfer function of the system, we can find pole zero of the system. So that is a very important thing, because poles and zeros tells a lot of things about the system. Poles are telling me which are the points where the system gain becomes infinite, because if suppose if you are substituting s is equal to -4 here, okay, in this case s is equal to -4 is the position of the pole. So if you are substituting s is equal to -4 here, then you find denominator is coming to be 0. If denominator is coming to be 0, overall system CS by RS, which is also we are sometimes calling as gain. Okay, we call it not gain, we call it system transfer function. So if you substitute s is equal to -4, whole system will become infinite, because denominator will become 0, and anything by 0 it will become infinite. Okay, like this. So poles are the points where the system gain is becoming infinite. Zeros are the points. So if you are substituting s is equal to -3, then this part becomes 0. If this part becomes 0, the whole CS by R is becomes 0. So zeros are the points at which, or zeros are the frequency at which the system gain becomes 0. Okay. So these are the things we can know from the transfer function. Then from the transfer function denominator characteristic equation, we can find out whether the system poles are real pole or imaginary pole, whether the poles are lying in the left hand side or right hand side, that we can find from pole zero diagram. And if you are finding that system poles are in the left hand side of the system, we can call that system as a stable system. And if you are finding poles are there in the right hand side of the system, we can call that system as a unstable system. So for this system given, we are finding denominator is having equation of s cube plus 18s square plus 40, 6s square plus 18s plus 40, like this you can see here. So this is a characteristic equation. All poles are there in the left hand side, system is stable, and s cube. So this is the order of the 3. That means the system will be having 3 energy storing elements. So this is the significance of transfer function. Now we will see another numerical, so last numerical of this session, which is called, so you can take the screenshot of the bottom part, which is saying find the system transfer function by signal flow graph. So this is a very simple example I have taken because I just want to show you what is or how to find the signal flow graph based transfer function. So please take the screenshot of the diagram which is given below, and I have shown the solution, and just let me know if the screenshot is taken. So find the system transfer function by signal flow graph. This is what we want. Okay. So Chaitanya is doing very well, it seems. I think there are how many? There are only 3 people. So Chetan and Sridhar also, you take the screenshot, just let me know if things are taken. Okay. So what we'll do is, we'll find out what is, okay, how to find the transfer function of the system. Now in this, whenever I'm giving you signal flow graph, first thing you are supposed to check that how many paths are there where gains are not marked. So this one might not be marked. This one might not be said here, so only one arrow mark is given here like this. It is also possible. Between this G5 and CS also this one arrow mark is given, so this one might not be written. So if nothing is written, you have to consider that as gain 1. So that path gain is given by 1. What are the things to check here? So we know that the rule we are using here is Mason's gain formula. Okay, so what is meant by Mason's gain formula? Mason's gain formula is nothing but finding the system transfer function by signal flow graph in one shot. Okay. But in one shot, to do that, we have to have some basic understanding of that. So what is the first thing? First thing, we are supposed to check how many forward paths are there and how many loops are there, and if there is any loop which is not touched by a forward path. And there is a third thing, and fourth thing, how many loops are there who are non-touching. So there are only 4 things I'm telling you, just remember, or you can write down. First thing is how many forward paths are there. So in this case we are finding that, just check, start from R and go to C. So this is the first G1 into 1, so that is G1, G2, G4, G5. So this is the first forward path, which is the line which are exactly at the center. So G1, G2, G4, G5 likewise. Okay. Second path is, it is coming to G1, after coming to this point it is going up. Okay, this is G3. So G1, G3, then G4, G5. So this is another path. So there are 2 forward paths. One forward path P1 is G1, G2, G4, G5. So G1, G2, G4, G5. This is one forward path. Another forward path is G1, G3, G4, G5. So P2 is G1, G3, G4, G5. There are no forward paths other than these 2. And just check how many loops are there. So how many loops are there? First loop is G1 and minus H1. What does this minus indicate? This minus indicate that this is a negative feedback path. Okay. So 2 loops, L1, what is the loop gain? So forward path gain multiplied by feedback gain is called as loop gain, or open loop transfer function, OLTF. We have seen that. So G multiplied by H is called as open loop gain or OLTF. So this is minus G1 H1. So for loop 1 it is minus G1 H1, and for this loop there is a second loop. So there are only two loops, and second loop it is minus G4 G5 H2. So this minus H2 is the negative feedback gain, and G4 G5 is the forward path gain. So G4 G5 minus H2, this becomes a negative feedback gain. Now writing is very easy, but you have to understand the things which are coming next. Okay, so from Mason's gun formula point of view, now you have to check how many loops are there. So there are only two loops. One is G1 H1 minus, another is minus H2 G4 G5. Whether these two loops are touched by the forward path. So if you check this central or first forward path, this forward path is touching this minus G1 H1. This forward path is also touching this minus H2 G4 G5. Hence, in the numerator G4 G5 and this, no other additions have to be done in the forward path. Just give me 1 second. Okay, so this is the thing. So P1, G1, G2, G4, G5, main thing we have to check if there is any loop which is not touched by a forward path. If there is a loop which is not touched by a forward path, suppose that was having gain of maybe G2, H2, that we have to write here 1 plus G2, H2. But here all the loops are touched by all the forward paths. Then it's a simple case. Then directly we can go for writing Mason's gain formula. Okay, and one more thing we have to check. These loops are there, whether these loops are touching or non-touching. Now there are two loops. One is G1, H2. See, this is not a loop. Be careful. G2, G3 is not a loop because G2 is also going forward. G3 is also going forward. What is a loop? Starting point and ending point is same. So G1 is going forward and H1 is coming back. That's why this is called a loop. G2, G4 is going forward and H2 is coming back. That's why this is called as a loop. So what is the definition of loop? Whatever is the starting point, it is going there and forward and again coming back. So that's why this is called as a loop. This is also a loop because G1 is coming back and G1, H1 is coming to the same point. That's why this is a loop. But G2, G3 is not a loop because it is going forward and G3 is also forward. Okay, G3 is not coming back. So that's why G2, G3 is not a loop. Both these two things are forward path. Together we can write one line and we can write the overall gain of this path as G2 plus G3. In that case our job becomes easy. Okay, but anyways, so this is, there are two forward paths, P1 and P2. There are two loops, L1 and L2, and L1 and L2 are not touching each other. That is a very important thing. So that thing will reflect at the denominator of CS by RS. So the question is, find system transfer function by signal flow graph. Okay, and we are finding it by Mason's gun formula, and Mason's gun formula gives us very easy way of determining the transfer function. But in the exam, don't write the transfer function in one line. You can write that, but you have to write every of this thing clearly. So this question might be asked for 8 or 10 marks. So directly if you are writing the transfer function in one shot, CS by RS is equal to this much, with very much practice you can write that, but in that case 4 or 5 marks will be given to you and will deduct 4 or 5 marks because you have to show that you have understood every step of it. Okay, so I have also not done in very big manner or elaborate manner, but when you are doing in the exam you have to write everything elaborately. So what are the things you can write? First thing you have to write, P1 is equal to G1, G2, G4, G5. This is the first forward path. Second forward path is G1, G3, G4, G5. This is the second forward path. Third thing you have to write, there are two loops, feedback loops. First loop gain L1 is minus G1 H1, second L2 is minus G4 G5 H2. So this thing, and then you have to write these two loops, that is G1 H1 and G4 G5 H2. They are non-touching. Okay, so their combined loop gain, if you are just seeing the denominator, these two loop gain will be multiplied. So after multiplication, combined loop gain will be G1 H1 multiplied by H2 G4 G5. So it will be G1 G4 G5 H1 H2. That part you have to write, and that part will come at the denominator. Now let us see how to implement Mason's gun formula and how to write the transfer function of this overall system. So it is given here, in this diagram. I'll just reduce the size of the diagram little bit, and let us see. Okay, so those who are there, you can take the screenshot. So both forward paths touching both the loops. That is one very important thing you have to write. That there is no any loop which are not touched by the forward path. So both forward paths are touching both the loops. So CS by RS. So this is actually Mason's-Gain formula. CS by RS is given by forward path gains. So what are the forward path gains? You can see here G1, G2, G4, G5 plus G1, G3, G4, G5. So these two are the things which are the forward paths. Okay. So Mason's-Gain formula, first thing you have to write what are the forward path gains, and G1, G2, G4, G5 and G1, G3, G4, G5. And if there was any loop which is not touched by this, so that you had to multiply here. So G1, G2, G4, G5 into 1 plus of that gain. Okay. But here, as both the loops are touched by the forward paths, you just write the forward path gains total. Denominator part is what you find difficult to understand, but there is nothing difficult. What is the rule? Rule is 1 minus summation of single loop gains. So what are the loop gains? First loop is minus G1 H1, second one is minus G4 G5 H2, and symbols are very important. Okay. So first loop is having gain of minus G1 H1, second loop is having minus G4 G5 H2. So summation of single loop gains. So 1 minus of, so this is the minus of the formula, plus of the formula, minus of the formula. So what does Mason's-Gain say? That 1 minus summation of single loop gains plus multiplication of loop gains of two non-touching loops. So in this case, this term exists because we find there are two loops which are non-touching. So what? How do I write that? So plus of minus G1 H1 multiplied by G4 G5 H2, like this. Okay, so overall thing, if you are writing, so CS by RS, first is addition of all the forward paths. So G1, G2, G4, G5 plus G1, G3, G4, G5. This is the forward path. Denominator 1 minus single loop gains, an addition of that with symbol. So minus G1, H1 is one loop, minus G4, G5, H2 is the other loop. So 1 minus of these two things. Plus multiplication of single loop gains which are non-touching. So there are two loops which are non-touching. First one is minus G1 H1, second loop is minus G4 G5 H2. So multiplication of that, minus multiplication of gain of three non-touching loops. So if there is any system where there are three non-touching loops, so minus of gain of all those three loops you have to multiply. The loop gains you have to multiply. But the three non-touching loop is not the case here. Only two non-touching loops we are having. So numerator is addition of all the forward path gains divided by denominator 1 minus, this is single loop, this is single loop, their addition plus the two non-touching loops multiplication of their gain, like this. And then last line, if you are just CS by RS becomes G1 G2 G4 G4 G5 plus G1 G3 G4 G5, likewise, and this minus minus becomes plus, this minus minus becomes plus, so this becomes 1 plus G1 H1 plus G4 G5 H2, plus of these two minus cancels each other, so G1 G4 G5 and H1 H2, likewise. So overall transfer function CS by RS, G1 G2 G4 G5 plus G1 G3 G4 G5 divided by 1 plus G1 H1 plus G4 G5 H2 plus G1 G4 G5 H1 H2. So this finishes the very basic numericals, which are finding the transfer function of the system by using block reduction technique and by using signal flow graph. And then after finding the CS by RS, what is the use of that transfer function? So actually transfer function gives us insight about any system. So transfer function of the system gives us the characteristic equation. That is nothing but the denominator of transfer function equated to 0. And from that characteristic equation, we can find out what are the poles of the system. From the numerator, we can find out what are the zeros of the system. Then we plot all the poles and zeros in the S-plane. And after finding the pole zero diagram in the S-plane, then we check what is the position of pole and zero in the S-plane. If you are finding all the poles are there in the left hand side of the S-plane, that is left hand side of j omega axis, we can say that the system is perfectly stable. In that case, we will be finding that as time goes by, the system time response will touch the zero axis as time goes by. And if the system is unstable, we will find that as time goes by, as t tends to infinity, the system output amplitude also will tend to infinity for a certain kind of input. Okay, so if the area under the curve is finite, then we call that system as energy system, we call it as a stable system. If we find that system, the characteristic equation response or the system response is increasing over time as t tends to infinity, the output amplitude tends to infinity, in that case we call that system as unstable system. So area under the curve is infinite as t tends to infinity, then the system is called as a unstable system. So the stability analysis of the system can be done from this CS by RS. So this is everything about transfer function and finding transfer function by two methods and what is the use of that transfer function. Okay, so again we will meet at 2:30 today. We'll be solving some different numericals. So we'll finish the chapter 2 and we will start with module 3. Those things we will see at 2:30. So please be there on time. The link is already posted to you. The same link is not there, so there's different links generated for every hour of Google Meet. So see you all at 2:30, and if you are having any doubt, you can send me the doubts in the WhatsApp group. That's all. Thank you.